Hi there everybody, I'm Forrest, the Renegade Science Teacher, and welcome to the very first episode of ScienTEST, the show where an actual scientist, hi that's me, I'm Forrest, unboxes, tests, and savagely reviews science kits intended for small children. And for today's episode, we'll be testing the Discovery Extreme Chemistry Lab. I'm actually pretty excited about this. I grew up watching a lot of Discovery Channel, and I've always wanted my own Discovery Channel show until they started talking about how mermaids might be real because nobody can prove that they aren't real, I guess. But I've always had some faith in their products. And this one in particular boasts over 20 different experiments, including a bubbling experiment, putting out fire, testing your foods, making your own worms, ice melting. That sounds cool. And I went ahead and pulled out the instruction manual so I could take a quick peek through it and make sure I have all the materials that I need, because there's a lot of stuff that isn't included in the kit, but this has got almost 30 experiments in it. I'm very excited to get started. So let's open this bad boy up. Alright, so we've got some good little test tubes here. Pipette, that's very nice. Litmus powder, that'll be interesting. Tartaric acid, another test tube. What have we got? Sodium alginate and, of course, calcium chloride to go with that. We'll keep those together. A few more test tubes. I love how many test tubes they're giving us. Popsicle sticks, the most important tool in any chemistry lab. A plastic spoon. Looks like some paint. A little bit of baking soda. Aw, hell yeah. Stickers! We'll get rid of this. Wait. We'll get rid of this. Get in there. Why? Why? There we go. There we go. There we go. There we go. And then this little piece, I guess, just sticks right into this hole. Yes! I love how little assembly was required with our setup here. It seems a lot nicer to be able to have this thing ready to go than focusing on putting together all the pieces just to have a stand for the actual science experiments. I'm not gonna put the glow-in-the-dark stickers on it. Artistic expression makes me incredibly uncomfortable, so I'm just gonna set those to the side and set up our little chemistry set, maybe. Where's... there. That'll be fine. And then we can put in our test tubes here, like that. And this one on the little stands. Isn't that nice? And then this one is, I guess, extra. There. And now we can finally get started. Let's take a look inside at experiment number 1, bubbling experiment. All you need is your baking soda right here, some vinegar, which is not included, so I brought mine. The vinegar that I use for my chemistry shows is cleaning vinegar, so it's way stronger than the stuff you'd find in your kitchen, but I actually don't have any regular vinegar just laying around, so we're gonna go with the strong stuff. Then you need a pipette, a test tube, and a spoon. Instructions: pour 1 spoonful of baking soda into a test tube. Boy, this spoon is not conducive to getting into a test tube. Now I wonder what we're gonna do with this baking soda. Fill a pipette with vinegar and slowly drop it into the test tube. Watch the reaction occur. Here's our vinegar going into our pipette and dropping into our test tube. And would you look at that? It's a bubbling reaction. The combination of the vinegar and baking soda creates carbon dioxide gas. And that's it. That's literally all it says. Why wouldn't it say more? This does nothing to actually teach you the science behind what's happening. All you know is that you mixed baking soda and vinegar and you released carbon dioxide gas. and that's what made the bubbling reaction. So right away, this is a big mark against this science kit. It doesn't actually teach you science. You're just doing a thing and going ooh at it. Granted, this kit is designed for kids, but it says 12 plus on the bottom of the box, and like, a 12-year-old could absolutely understand what's actually going on here. So what you're seeing here is what's called an acid and base reaction. And there's actually about 3 different models for how acids and bases work. My favorite one, the one that I think is easiest to explain to kids, is that acids contain a high concentration of hydrogen ions, and bases contain a high concentration of hydroxide ions, which is just an oxygen and a hydrogen together. So you've got H plus and OH minus, and when you combine the two, the plus and minus cancel each other out, and you're left with 2 H's and 1 O, which makes H2O, water. In fact, when you measure acids and bases, we use what's called the pH scale, which goes from 1 to 14. 1 being the most acidic, 14 being the most basic. And right in the middle at 7 is pure water. Pure, neutralized, not acid, not base at all. And that's what we're making here. The vinegar is acidic, the baking soda is basic, and together they're making water, and carbon dioxide is just a byproduct. You could absolutely explain that in this packet. But I guess they were more interested in just cramming on as many experiments as possible, because the next experiment is the exact same thing, but you add dish soap. It even says, follow the instructions from experiment 1, but add a drop of dish soap. That's all it says. So we can dump out this old test tube now, add some more baking soda, add a drop of dish soap, and now when we add our vinegar, we get a big tower of foamy bubbles. This is another really cool experiment that could have like a whole beautiful explanation. You could write a paragraph about what's going on here, but instead, all they say is, do it. And sure enough, the next experiment is mixing baking soda, and instead of vinegar, you use tartaric acid. So I haven't actually learned any new science here. All I've done is I've basically made a bath bomb in a test tube. This is already annoying me, so I'm going to move on to the next experiment, which is the eternal flame. Ask an adult to help with this experiment. Why am I looking? I'm almost 30. I can do this alone, can't I? In a clean, dry test tube, mix 1 spoonful of baking soda with 1 spoonful of tartaric acid. If you're gonna do an acid-base reaction with dry ingredients, you should really make sure they're well mixed. They don't tell you that in this, but they really should if it was a good teaching kit. Ask a parent or guardian to light a match. Quickly remove the paper and insert the burning match into the test tube. Does it keep burning? What paper? These are all the instructions. Ask an adult to help with the experiment. In a clean, dry test tube, mix 1 spoonful of baking soda and 1 spoonful of tartaric acid. Ask a parent or guardian to light a match, quickly remove the paper, and insert the burning match in the test tube. Does it keep burning? Today, most fire extinguishers contain carbon dioxide gas. They forgot to include all the instructions. This isn't going to create any carbon dioxide gas unless there's water involved. But I guess we'll go ahead and do it. Here's another cup with some fresh water in it. I've got some matches, and even though they didn't include fire safety on the instructions, I came prepared. Light a match, and with all the hands we have, quickly put water in here to start the reaction and put the match. Yes. Whoo! They didn't talk about the fact that you're going to burn your fingers when you invert the match into the test tube, but if you're quick, that won't happen. The next experiment is called the disappearing flame, and guess what you do? It's the exact same thing, but with a piece of paper on it. So you were supposed to do number 5 first, because this one is all about putting a special piece of paper that you cut with scissors on top of the test tube so that you have like a funnel. Who organized this? And then on number 6, you do the exact same experiment again, but pour the carbon dioxide on a candle. And don't forget, this comes right after the first 3 experiments that did the exact same thing. Is this going to be a pattern throughout all 30 experiments? Do we only get like 10 crappy experiments in this? Let's find out with the next series, which is all about litmus tests. So a litmus test, for those of you who don't know, is a quick and easy way to test the acidity or alkalinity of a solution. Basically telling you what kind of acid or base you're working with. So we're coming up on experiment 7, and every single one of them has had something to do with mixing acids and bases together, and they still have not taught us what an acid or a base is. Litmus experiment number 1. Pour less than half a spoonful of litmus powder into a test tube. Add enough water so the test tube is filled halfway. Put on the cap and shake it up. Set aside for 1 day so the litmus solution can form. Store the solution, keep it... What? Store the solution, keep it in a dark place to preserve the shelf life. I don't think anyone proofread this instruction manual either. So I don't really have a full day to record this, but I'll go ahead and make the litmus solution, and then with the magic of editing, I can put in how the experiments turned out later on, if they're any good at all. So right away you'll notice that the solution is purple. This is probably using something like flavin, which is an anthocyanin. It's a chemical that you can find in things like red cabbage and a lot of other organic matter as well. And when it's just totally neutral, it's purple, but it's going to turn red when it's exposed to acids, and probably like green, if I remember correctly, when it's exposed to bases. But instead of messing with that for right now, I actually brought some of my own universal indicator solution, which includes this flavin and phenolphthalein and a few other really great pH indicators, so you get a full rainbow of colors with this bottle right here. Fill a test tube 3/4 of the way with water. Use a pipette to add 7 drops of litmus solution. Close the test tube and shake. You might have gotten 8 in there, assuming. Huh. Our water here is just a little bit basic. With a clean pipette, add 1 drop of vinegar to the test tube and shake it a little. What do you see? It should turn red. The color red shows that the item you have tested is an acid. Just for curiosity's sake, let's test this out with the litmus solution, having had it just set up for like a couple of minutes. And we already get a pretty good reaction. I don't know why they want you to wait all night for this. Like, it's possible that it'll disassociate more into the water and become a little bit better to work with, but I've never seen anything tell me to wait a long time setting up a pH indicator like this. They should be pretty instantly effective. So I'm reading ahead a little bit, and I'm noticing a pattern here. Litmus experiment number 1 was just making the litmus solution, which isn't an experiment. You literally just made a chemical for later. Experiment number 2 is what we just did, adding the litmus to a little bit of vinegar and seeing it turn red. Experiment number 3 is using the tartaric acid and making it turn red. Experiment number 4 is adding orange juice and seeing it turn red. Experiment number 5 is adding baking soda and then vinegar again and making it turn red. Experiment number 6 is just a copy of experiment number 3 where you add tartaric acid again and make it turn red. And this trend continues through experiment 7 and into the next experiment, which isn't called litmus experiment number 8. It's called test your foods, where you take the same litmus solution and test things like lemon and tomato, which are both acidic, so it's gonna turn red. Alright, here we are 24 hours later with the litmus solution, and the same weak acid as in the first experiment. Let's see if it makes a difference. And it's turning red the exact same way it did last time. Because why would it do anything else? This kit was $20. So out of our 29 experiments, one of them is just making the chemical that we're gonna use for the next 8 experiments, all of which turn that chemical red over and over again. This is 14 experiments in. They still haven't explained how acids and bases work at all. We still don't know why this turns red. We still don't know what the chemicals we're putting in it are besides like their names. So I'm gonna go ahead and skip those experiments and move on to number 15, make your own worms. This is another one that I'm pretty familiar with. I've been doing this experiment for like the past 8 years. It's a lot of fun when you do it right. So let's see how they tell us to do it. We're gonna need a cup and we're going to need to put some water in it. And then it wants us to mix in our glitter paint, which I'm guessing is this right here. Oh god. Oh, I don't want to get this everywhere. How do I get this into the cup? Do I use a stick? What makes this glitter paint? Is it shiny? Oh, it's just stuck on the stick. I don't know how much of this I'm supposed to put in there. It's really not coming off the stick very well, and it's not really dissolving into the water very well. It kind of just looks awful. Get off the stick! Get off the stick! So now we have some horrible blue water, and I'm going to set that right there. Then it wants us to mix in the whole bag of sodium alginate, so you really only get to do this one once. Once again, I've done this experiment about 3 million times. You don't need this much at all. Here's a pro tip for you, by the way. If you ever do this experiment, don't do it in this order. Put the sodium alginate in first and mix water into that. Otherwise, you get what you've got going on here, where you just have these awful lumps of sodium alginate floating around in the water, not able to fully dissolve. So I've been stirring this sodium alginate for about 5 minutes now, and I've been trying to just really meticulously go through here and like squish up every one of these little chunks and make sure that all the powder gets into the water, and it's just not happening. So I'm going to go ahead and just set this aside and call that a heaping spoonful of good enough and move on to the next step. In a second cup, add half the bag of calcium chloride with 1 cup of water, stir until dissolved. Oh wait, I can put this on our little display there. Isn't that nice? Use the pipette to draw up some of the sodium alginate mixture. Yeah, good luck. Then slowly and steadily drop a stream of the sodium alginate into the calcium chloride mixture. I hope we're not going to be using this pipette for anything else. Swirl the calcium chloride solution with a spoon. Pull out the slimy strands that look like worms. Swirl it a bit. And here is our worm. So once again, we've done a really cool experiment, and we have absolutely no idea what we actually did. I used to work for a children's science museum, and we did this experiment all the time for kids, and it would literally take an hour to do this experiment over and over, explaining the science behind it, testing different variables, having the kids do it themselves, having them mix up their own solution. There is so much cool science going on right here that they're just flatly refusing to tell us. It's not like they don't have the paper space. Take away half of the litmus experiments that do the exact same thing and teach us the science of what's going on here. Basically, the sodium alginate is made of these long, slimy molecular strands that mix in with the ions in the calcium chloride to bind together and form this horrible little gel. If you leave this in the solution longer, they'll just get harder and harder. But right now, it actually polymerized so fast that it's still got a liquid center because only the outside was able to harden. If you've ever eaten popping boba, this is exactly how it's made. They take sodium alginate, mix it with a bunch of flavoring, and then they drop little balls like this into a solution of either calcium chloride or calcium lactate, and it forms these little bubbles of delicious flavor. You could teach so much cool science with this kit, and they're just refusing to do it. And wouldn't you believe it, experiment 16, 17, and 18 go back to testing litmus powder. So I miscounted earlier, it's not 7 experiments, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 experiments, all centered around checking what the pH of a solution is, and they have never once explained what pH is or how it works. Darwin's beard, man. I'm gonna go ahead and skip ahead here to experiment number 23, tartaric acid solution. Dissolve 1 spoonful of tartaric acid in half a test tube of water and shake. This is a tartaric acid solution. Experiment 24. That's the whole thing? Number 23, tartaric acid solution. Supplies, test tube, tartaric acid, water, not included. Instructions, dissolve 1 spoonful of tartaric acid in half a test tube of water and shake. This is a tartaric acid solution. That's the whole experiment. That's not an experiment. All I did was make a solution that's doing nothing currently. If this is an experiment, then I'm doing a science experiment every time I add sugar to my iced tea. Number 24, foam test. Supplies, test tube. We're out of test tubes. I'm gonna use a cup again. Add 2 drops of liquid soap into a test tube and fill with water. Cover the test tube and shake. I'm just going to use our water cup from before and add a little bit of soap to it. Use the pipette to add a few drops of tartaric acid solution from experiment number 23. Again, not an experiment, and our pipette is currently full of worm goo. So we're just going to pour a little bit in. Okay, we've done it. What happens? Foam doesn't disappear. And that's the end of the experiment. I'm about to lose my mind. This is the most frustrating science kit I've ever seen. And it's our first one. What is the rest of this series going to look like? This is a kit boasting almost 30 experiments, most of which are just making things that you need for other experiments, and absolutely none of which is actually teaching you science. The last experiment, number 29, is literally just taking the calcium chloride, pouring it into a bowl by itself, and leaving it out for 3 days. Supposedly, after the first day, it will have turned into a liquid brine because, and this is the first thing they've said that's actually relevant, calcium chloride is hygroscopic, meaning it attracts moisture from the surrounding air. But then after a couple more days, it should solidify again because the lack of moisture causes it to release heat and crystallize again. So you just leave it out for 3 days to see what happens. Any science kit that's going to tell you to leave something out for days on end and just check it once a day is not exciting for kids. How is that hard to understand? But speaking of exciting, I've saved the best experiment for last. Number 26, ice melting. Supplies, ice, not included. And our old friend, the calcium chloride. We'll put that right here. Sprinkle 1/8 of the bag of calcium chloride onto an ice cube and see what happens. There we go. There's a few pieces of calcium chloride there on the ice cube. It melts. It says it right here. It melts. And there you can see it sure is melting. Just slightly faster than it would be melting at room temperature. Because calcium chloride is hygroscopic, and dissolving it in water is an exothermic reaction, causes the water to heat up a bit, changes the freezing point, kind of like salt does. Look, they actually have like a whole half a page here of space to put in what's actually going on with this calcium chloride. And it's not that they can't, it's that they refuse to. What's happening here at a molecular level is actually pretty flippin' cool. And a 12-year-old would absolutely be able to understand it if you just tell them. But this science kit seems to actually be going out of its way at this point to try to just make more experiments without actually packaging anything of value. It's almost as if they just want your money and aren't actually trying to teach you anything. This kit is immensely frustrating and disappointing to me. I would not recommend it to anybody who wants to learn science, especially not somebody who's 12 and up. If you're looking for something to waste your time with for a few days, sure, you can spend a whole day waiting for Litmus Solution to dissolve, and then you can spend another few days watching calcium chloride do nothing in a bowl. But if you want to actually learn chemistry, the Extreme Chemistry Lab does not seem like the place that I'd want to go. Thanks so much for joining me for the astonishingly underwhelming first episode of ScienTEST. If you enjoyed this video and you'd like to see more like it, be sure to hit the like button and drop me a subscribe as well if I've earned it. I'm Forrest, the Renegade Science Teacher. Have an awesome day, and remember, never stop learning. Can I get a hell yeah?
Hell yeah!
Hell yeah!